everybody, it's Ms. Lacknew, and this is going to be our first lesson that we're covering. So we're going to be doing adding, subtracting, and multiplying polynomials today. And if you remember, we've definitely done this in the past, so it's pretty much just going to be a review this week. So we're going to get started with adding and subtracting. Now if we look at this first one over here, it's 5p squared minus 3p minus 2p squared minus 4p. And what we learned was that this subtraction sign right here, it had to change the signs of everything after it. So changes the signs. And of course, that only applies to the two after it. So really, it's distributing this negative to both of these terms inside the parentheses after. So I'm going to keep these first two the same. So it's going to be 5p squared minus 3p. Then this positive 2p squared is going to turn into a negative 2p squared. And this negative 4p is going to turn into a positive 4p. Now all we have to do is figure out what our like terms are, and we have to start at the highest degree. And what that means is we need to start at the highest exponent. So our highest exponent is 5p squared. And the one that's a like term, meaning it has the same degree, is negative 2p squared. So I'm going to write those two next to each other because I know I'm going to have to combine those. And if you can combine those in your head, you can go ahead and do that. But I'm going to write them next to each other just so I don't get confused. And then our next highest degree is negative 3p. And the same degree as negative 3p is this positive 4p. So I'm going to write these next to each other. So minus 3p plus 4p. Now if you notice, I'm using shapes. You can do that if you don't have different colors. I'm also using different colors. Both of these just kind of help to keep it organized. So then our final answer, we're going to take 5p squared and negative 2p squared and combine those like terms. So 5 minus 2 is 3p squared. And then negative 3p and positive 4p, negative 3 plus 4 would be positive 1p. And that right there would be our final answer. Now with number 2, notice we have a plus sign right here. The plus sign means that we don't have to change anything. So I'm going to rewrite these outside of the parentheses. And I will have 4x plus 2x squared. Then these signs will stay the same, so it'll be a positive 5x squared and a positive 2. Now we're going to do what we did here with the shapes. So I'm going to start with my highest degree, which is 2x squared. So square is our highest degree here. And of course, the one that matches that is 5x squared. So I'm going to write those two next to each other. We'll have 2x squared and 5x squared. Both are positive. And then my other one I have is 4x. And notice nothing else matches that 4x, so I'm just going to write 4x by itself. It doesn't have to have a like term. And then we have 2. So 2 is a constant. That's the only constant we have. So I'm just going to rewrite plus 2. Now that I have all of these, I can just go ahead and find out what my answer is. So combine the like terms. The only like terms that we have are 2x squared and 5x squared. 2x squared plus 5x squared gives us 7x squared. 4x doesn't have any like terms, so plus 4x. 2 doesn't have any like terms, so plus 2. And that will be our answer. So the big takeaway here, if there's a subtraction sign in between, remember to distribute that negative and change both of these signs. There's a positive sign in between, so a plus. We don't have to change this parentheses at all. All right, moving on to number 3 and number 4. So number 3, notice we have a plus sign in between. So we're going to start this one off by just rewriting everything outside of the parentheses. So 4k squared plus 14 plus 3k. Since we have a plus sign, we don't need to change any of these. There's nothing to distribute. So it's going to stay negative 3k squared minus 14k minus 8. You don't really have to rewrite it like this. I just like rewriting it bigger than it is up here, so I have room to make my shapes around each of them. But you really don't have to rewrite all of them. So then I look for my highest degree, and if I can see, it's the squared. So the exponent is a 2. So I have negative 4k squared. And the like term with negative 4k squared is negative 3k squared. And then my next one, I have positive 3k and negative 14k. And last we have our constants. So I have 14 and negative 8. So plus 14 minus 8. Now all we're going to have to do is combine our like terms to get our answer. So negative 4k squared minus 3k squared. We're just combining these two. They're both a negative, which means our final answer is going to be a negative. Then the 4 plus the 3 is 7. The k squared will stay a k squared. Remember not to add your exponents. Then I have 3k and negative 14k. When we combine those, it's 3 minus 14. So that's going to be negative 11k. And 14 and negative 8, when you combine those, we get a positive 6. So negative 7k squared minus 11k plus 6 is our final answer here. The next one, we have this negative subtraction sign in between. That means we need to change all of these signs. So it's going to be 3 minus 6n squared minus 8n. Those will not change. Only the ones after the subtraction sign, that's where we distribute, and those have to change. So this negative 6n turns into a positive 6n. Negative 3 turns into a positive 3. Negative 8n squared turns into a positive 8n squared. And the reason why it changes, this right here is a negative 1. You're distributing, so it's negative 1 times a negative 6. Negative times a negative, that becomes the positive 6. Negative 1 times negative 3 becomes the positive 3. Negative 1 times negative 8 becomes the positive 8. So that's the whole reason why we're changing everything in that second parentheses. Now we just have to find our like terms. So I'm going to start with my highest degree, which is the squared. So negative 6n squared and positive 8n squared. Oops. And then we go to our next ones, negative 8n and positive 6n. And last, we have positive 3 and positive 3. Now we just combine these like terms. So negative 6n squared plus 8n squared is going to give us 2n squared. Negative 8n plus 6n is negative 2n. And 3 plus 3 gives us 6. So that'll be our final answer. So that's all there really is to adding and subtracting polynomials. Now we're going to move on to multiplying. So with multiplying polynomials, this is where we used our box method. So we first have to look at how many terms are in each of these. So 1, 2. A term is just this. So we just count 1, 2. There's 2 terms here. 1, 2. 2 terms here. So we need a 2 by 2 box. So I'm just going to draw that box. So you see 2 by 2. Now what I'm going to do, I'm going to take this first one and I'm going to put it on top. So the first term lines up with the first box. The second term lines up with the second box. Then I come to this one and it's the same thing. The first term goes with the first box down the side. Second term goes with the second box. Now what we're going to have to do is just multiply. So I have 2n times 4n. So actually I'm going to write this inside the box. Oops. So here it's going to be 2n times 4n. So you just take the two things that lead to that box, and that's what we're multiplying. With the numbers, you multiply them with like normal. So 2 times 4 gives us 8. And n times n. So remember, if you have n times n, there's really an exponent of 1 on each of those. And as we learned before, when you're multiplying, you add your exponents together. So it's n 1 plus 1, which would give us n squared. So 8n squared is what goes in that box. For this box right here, that's going to be 2n times 1. 2n times 1. Anything times 1 is just itself, so we'd get 2n. For this one, we have 4n times 6. 4 times 6 is 24. Then we only have 1n, so just 24n. In our last box, we have 6 times 1, which of course is 6. Now what we need to do is just take all of these terms that we found. So 8n squared, 2n, 24n, and 6. And we're going to write those out. So 8n squared plus 2n plus 24n plus 6. So this is almost our answer, except we have some like terms. So if you notice here, we have 2n and 24n. When you add those together, we're going to end up with 8n squared, 2n plus 24n is 26n, and then plus 6. And that will be our final answer. All right, next up, it's going to be the same thing. So I'm going to make my box. And again, we have 2 terms here, 2 terms here. So we need a 2 by 2 box. 2 by 2. Get myself a little bit more room on this one. Now here I have 3m, but this time it's a -1 here, so it's -1, which means I'm going to put -1 on top of the box. And on down the side, I have 8m and 7. So the only time you need to put the sign on it, so if this is subtraction, you have to make that a negative. Now we're going to see what we get when we multiply. So this first one, we have 3m times 8n. And again, 3 times 8 is 24. Now m times m is the same thing we did here with the n's. So you add the exponents, which gives us m squared. Here we're going to have -1 times 8m. -1 times 8 is -8. Then, of course, we have the m. Then I have 3m times 7. 3 times 7 is 21. Then we have m. And last, we have -1 times 7. So -1 times 7 is -7. And once again, we just take all of our terms that we came up with. You really don't have to write these right here. If it helps you, though, you can. So I'm circling the important ones. And we're going to have 24m squared minus 8m plus 21m minus 7. Now we just look for our like terms, and we see we have them right here. So we have -8m and positive 21m, which means our final answer here will be 24m squared, -8 plus 21. That's going to end up being 13m. And then minus 7. And that will be our final answer. So 24m squared plus 13m minus 7. All right, moving on to the next two. So the only thing different about 3 and 4, this time it's not going to be a 2 by 2 box. So if we look here, this first one has 1, 2, 2 terms. The second one has 1, 2, 3 terms. So we're going to need a 2 by 3 box this time. And you can draw it any way that you want. If you want 2 on top, 3 down the side, that's fine. If you want 3 on top, 2 down the side, that's fine as well. Either way will work. So I'm going to do 3 down the side and 2 on top. So this is going to be our first box. On the top, we're going to have 4a and positive 2. And on the side here, I'm going to have 6a squared. Now this negative a, remember if there's no number in front, it's going to be a -1. I'm going to write that in just because it may help us. So -1a, same thing as -a, and positive 2. Now all we have to do is multiply like we did before. So I have 6a squared and 4a. So 6 times 4, it's going to be 24. Now here we have a squared times a to the first. And if you remember, you add them together. So 2 plus 1 should give us a to the power of 3. So you have to add your exponents together. For this next box, we have 6 times 2 is 12. And then the a squared is all we have, since there's no a on this one. -1a times 4a. So negative 1 times 4 is negative 4. A times A is A squared. Negative 1A times 2 is negative 2A. 4A times 2, so 4 times 2 is 8. And we have an A. And 2 times 2 is 4. So one way I like to tell my students to check themselves is to see if your diagonals have like terms. If your diagonals are not like terms, you probably did something with your exponents incorrectly. So on this diagonal here, we have A squareds. This one we have A's. And then these two on the ends don't have like terms. So if your diagonals are the same, that means you've done it correctly. So here our final answer, we're going to rewrite everything that's in this box. So it's going to be 24a to the third, 12a squared, negative 4a squared, negative 2a, 8a, and 4. So I'm just rewriting all 6 of these that I have inside the boxes out here, then we'll deal with our like terms. So my like terms, 24a to the third, that one doesn't have any. 12a squared, negative 4a squared, those are like terms. Negative 2a, and positive 8a, those are like terms. So our final answer here, we're going to have 24a to the third, 12a squared, and negative 4a squared. So 12 minus 4 is 8a squared. Negative 2a plus 8a, it's going to be 6a. And then that 4 doesn't have a like term, so plus 4. So this right here is going to be our answer. Number 4, again, is going to be a 2 by 3. So just to prove that we can do it the other way, I'm going to do this time, the 2 will be down the side, the 3 will be on the top. It's just going to show you that you can do it either way, it doesn't matter. So my 2 here, of course, has to be down the side, so I'm going to have 7k. Now it's minus 3, so this needs to be a negative 3. Now across the top, I'm going to have k squared, negative 2k, and 7. Now we just have to do exactly what we did in the last one. So there's no number in front of this k, so remember that means it's a 1. So 7 times 1 is 7. K times k squared is k to the third, because that's what we just did over here. 7k times negative 2k. So 7 times negative 2 is negative 14. K times k is k squared. 7 times 7 is 49. Then we have this k, so we put a k. Negative 3 times 1 is negative 3. Then we have that k squared, so I have a k squared here. Negative 3 times negative 2k. So negative 3 times negative 2 gives us positive 6 and k. And negative 3 times 7 is negative 21. So diagonal trick still works here. If you look, we have k squareds along this diagonal, k's along this diagonal. If those are not the same, you probably did something wrong. So now we're just going to rewrite all of the ones that we have. So 7k to the third minus 14k squared plus 49k minus 3k squared plus 6k minus 21. Now what we have to do now is find our like terms. We don't have any like terms with k to the third, so I'm going to move on to k to the second. There I have negative 14k squared and negative 3k squared. And we have 49k and 6k. Which means when we combine those, our final answer, we have 7k to the third by itself. Combine the k squared, so negative 14 plus negative 3 is negative 17k squared. 49k and 6k, that's going to give us positive 55k. And then this negative 21 doesn't have any like terms, so minus 21. And that'll be our answer. So these are the basics of what you're going to need to know. But now we're going to move on to some challenge problems if you just want to test your skills a little bit. Or if you're in period P, you need to do these. So our challenge problems, if you want to go ahead and try both of these right now, you can pause this video and try them on your own to see if you get the right answer. But I'm going to work through them right now. So we're going to start with number 1. Now this is just adding polynomials. There's just a lot going on within those polynomials. But really, it's not any harder than the ones that we just did. So my first step that I always like to do, since this is plus, we're not changing anything, but I still like to just rewrite everything. So it's going to be negative 4k squared plus 14 plus 3k plus 7k to the third plus 2. I'm just going to rewrite all of these. So negative 3k squared minus 14k minus 8 plus k to the third plus 6. Now all we need to do is find all of our like terms. So I'm going to start with my highest degree, which is going to be the power of 3's. So going along, I have 7k to the third, and then I just have 1k to the third. Remember, there's no number in front, but it's going to be a 1. So I'm going to write those two together. 7k to the third plus 1k to the third. Then I'm going to go to the next highest degree, which is the squareds. So I have negative 4k squared, negative 3k squared. That's all I see, so I'm going to write those next to each other. Negative 4k squared, negative 3k squared. Moving on, I look for just my k's. So I have 3k, negative 14k. And that's all the k's that I see. So plus 3k minus 14k. And last but not least, we have just our constants. So our constants, I have 14, positive 2, negative 8, and positive 6. So you can have as many like terms as you need. There really is no limit. So I'm going to rewrite all of those. So plus 14 plus 2 minus 8 plus 6. Now to get my final answer, I'm just going to combine all of those. So first we're going to start with the orange. 7k to the third and 1k to the third. 7 plus 1 gives me 8k to the third. Next are squareds. Negative 4k squared minus 3k squared gives us negative 7k squared. 3k minus 14k. So 3 minus 14 is going to be negative 11k. Now we have 4 here, so let's just take it one at a time. 14 plus 2 is 16. Minus 8 is 8. Plus 6 is 14. So plus 14. And that right there would be our final answer. So just because there's a lot of terms in there, it doesn't make it any harder. You still take the same steps that you did before. All right, number 2 and our last one. So this one's going to be our challenge multiplying problem. Again, you can pause it right now if you want to try it by yourself. So for this one, it is a 3 by 3 box. So 3 terms here, 3 terms here. So we're going to need a real big box for this one. So I need 3 columns, and I need 3 rows. Across the top, I'm going to have 2a squared, 3a, and 10. Along the side, I'm going to have 7a squared, negative 1a. So I'm going to add the negative 1 there, even though it's negative a, and 9. And now we just have to do all of the normal steps. We just have a lot more boxes to fill than we did in the other examples. Still going to do it the same way though. So 7 times 2 is 14. A squared times a squared. So I'm going to write this one out again. Remember, you add your exponents, so 2 plus 2 would give us a to the 4th. So 14, a to the 4th. Now 7a squared times 3a. 7 times 3 is 21. A squared times a to the 1st. You add them together and we get a to the 3rd. 7a squared times 10. So 7 times 10 is 70. Then we just have the a squared. Negative 1a times 2a squared. It's negative 2a to the 3rd. Negative 1a times 3a. Negative 1 times 3 is negative 3. A times a is a squared. Negative 1a times 10. Negative 1 times 10 is negative 10 with an a. 9 times 2a squared, 18 a squared. 9 times 3a, it's going to be 27a. And 9 times 10 is 90. So that's the hard part right there, is just filling them all in. And again, with diagonals, check to make sure you have like terms. If you do, you've done it correctly. Now all I'm going to do is take these, and I'm going to rewrite all of them. So it's going to be a lot. So 14a to the 4th plus 21a to the 3rd plus 70a squared minus 2a to the 3rd minus 3a squared minus 10a plus 18a squared plus 27a plus 90. Now we just have to find the like terms. So 14a to the fourth, that one doesn't have any. 21a to the third. That's going to be the same as negative 2a to the third. And that's it. Actually, I'm going to rewrite these as we go. So I'm going to have 14a to the fourth. Now, what are these two? They're like terms. When you combine them, 21 plus negative 2, that's going to give us 19a to the third. Next up, I have the a squared, so 70a squared, negative 3a squared, and 18a squared. So 70 minus 3, that's going to be 67a squared, and then 67 plus 18. That's going to give us 85. So down here, it's going to be plus, oops, I'm going to keep that purple. Maybe. So it's going to be plus 85a squared. Next up, we just have the a's. So I have negative 10a and 27a. So negative 10 plus 27 is 17. So plus 17a. And last, we have this 90, doesn't have a like term, so I'm just going to put plus 90. And this right here will be our final answer. And that's all there is to adding, subtracting, and multiplying polynomials. Check back with this or the written notes if you need any help with your assignment for the week, and let your teachers know if you need anything at all. Thanks.